So also note that x then I can express as r sine theta, right? Because sine is opposite over hypotenuse, x over r. X over r times r then gives me x. So then what is dx? It's going to be r times cosine theta times d theta. All right. So now I can rewrite this integral in terms of thetas, right, in different coordinates. So I've got my 2c out here. I'm not going to deal with these limits of integration just yet. First, I'm going to come in here and take care of this stuff. This root r squared minus x squared is r times cosine theta. Okay. Dx is also r cosine theta, but then also with the d theta there, right? So I got that stuff. And then what are my limits of integration? Well, let's see. So x equals r sine theta. So that means theta is sine inverse of x over r, isn't it? Now, so x was going from negative r to r, right? So that means x goes from negative r to r, implies theta goes from negative pi over 2 to pi over 2. Right? So I'll put negative pi over 2, like that. And then, so this is going to be 2c times integral, I can write this as r squared cosine squared theta, d theta, negative pi over 2, okay? And actually that r squared pops out. Let's see, what is the integral of cosine squared theta? Let's see, that's sine, if you remember from your trig part of your calculus class, it's going to be sine theta times cosine theta all over 2 plus theta over 2, and that's going to go from negative pi over 2 to pi over 2. Okay? And so I've got some 2's are going to cancel on that. And take a look at this. Note that, let's see, sine of pi over 2, cosine of pi over 2. Cosine of pi over 2 is 0, and cosine of negative pi over 2 is also 0. So this term is actually going to kind of wash out. And I'm just going to be left with, on the inside here, it's just going to be pi over 2 plus pi over 2. So it's CR squared times 2 pi over 2, or CR squared pi, right? But remember, all of this stuff equals 1. So all this implies, so 1 equals CR squared pi, or that C is 1 over pi r squared, just like we already knew, okay?